This video we're going to talk about Math 3, Unit 2, Worksheet 1, Analyzing Piecewise Defined Functions. This moves really nicely from Unit 1 to Unit 2. We left off with writing piecewise functions. Now we're going to learn how to talk about them, correct vocabulary, correct notation. And so one of the first words we see used is increasing, decreasing, and constant. So when they see the function going uphill, they would call that an increasing piece. Any place where it's going downhill, curved or straight, is a decreasing piece. And a constant part of the graph will be a line that is perfectly horizontal. These things are always defined on open intervals. At a place where something changes from increasing to decreasing, it is really hard to say at x equals 2 whether that's increasing or decreasing. And so we use open intervals for all defining the piecewise, increasing, decreasing, and constant. So on this graph, I first see that this is increasing, and it begins at negative infinity and goes all the way to the x value of 2, and we leave it open because it's not really there. Now, it's really common, especially when looking at increasing, decreasing, and constants, for students to want to talk about y because they see that they went up to 4 and they're thinking about up and down, so they very much want to say y values. I would emphasize that they always use x values to answer all interval questions except for range. Because x is the value that you plug into a function, f of x. X is the value we use to describe what's happening. The next thing that happens in this function is it heads downhill. So it appears that starting at 2 and going on to 4, that we are headed downhill. And then there's a second little piece of uphill. So that's often written with a union sign to show that there's more than one piece where this function's going uphill. 1, 2, 3, 4, 5, from 4 to 5, all open. And then at the end, it ends with a constant function where it is not gaining or losing and as far as the y value goes. And so I would say from 5 on to infinity, it appears to be constant. And so that's how you answer increasing, decreasing, and constant. Again, in these, students constantly are wanting to put y values instead of x values. So make a big deal about this using only x values when you're expressing these answers. That's what you're talking about. Okay. Some other terms that are pretty confusing as you go through the worksheet are relative maximums and minimums. I think we get the idea that they're high points and low points, but there's details about it that start to come up. So the actual definition of a relative maximum, which if they know this answers a lot of those questions, is it is a point where f of x is increasing before that x value and decreasing after. So yes, this is relative max. There it is. Increase, decrease, that's a relative max. We're going to give that as a point. Okay, we're not separating it out. Some of you who've taught advanced math or calculus, you know, they separate out where does the maximum occur, the x value, what is the maximum value of the function, the y value. We're talking about the point where the relative maximum and minimum occur. So that will be the answers on these. And then on this one, I see increasing and decreasing, but there's a whole bunch of points in there that have the same y value. Right here at this point, it increases before but does not decrease after, nor with any of these points does it decrease after. Here, it decreases after but doesn't increase before. So these guys right here are not a relative max. If we were doing calculus and we were learning about absolute maxes versus relative maxes, the absolute maximum value of the function is happening right here. If this is at a y equals 3, then the absolute highest that the function gets is 3. That's not what we're asking during this course. We're asking for points where f is increasing before and decreasing after. And so those are relative maxes and mins. That happens here, yes, here, no. Relative min is similarly defined. It's a point where f is decreasing before that x value and increasing after. So as we look at this graph, this definitely is a relative max. I'll just put rel max. Increase, decrease. This is a relative min. This increase, decrease is a relative max. This decrease, increase is a relative min. And these things bother people because this is a pretty high number to count as a relative min. There's all this stuff lower than it, but relative to the points around it, it's the lowest point in that little interval. And so that's why it's a relative min. It is not an absolute minimum. This guy seems like a min. It's definitely the lowest point of the function, and it is called an absolute min. Again, we're not teaching that in this course. We would not call it a minimum because it's not decreasing before. It's only increasing after. So this one is no. It's not a min. And it's really tempting to say that. And a lot of students would argue with there is no maximum because it keeps going up and up. There's lots of higher values than 3 or 4, or they might only want to put that one. But again, relative to all his neighbors, he is the highest point around. Okay? As if students were in a class, you're in second period, you're in fourth period, you might have the highest grade in second period. You're a big deal. Okay? But fourth period, there's somebody that's beating you. That doesn't take away the fact that you're a relative maximum and maybe not an absolute maximum. Okay. And so those are just some picky spots on these worksheets. As I look at worksheet 1, the most common thing, again, is for them to say answers wrong. And so they wanted the open interval where f is increasing. Again, we're using x values. So a lot of times I'll get 0 to 6 on this, but it's increasing from -3 to 3. In this x range, the function is headed uphill. It's decreasing from 3 to 7, not from 6 down to 3. No y values. We're answering in x values. The domain and range still are expressed in open or closed intervals, whatever is appropriate. These are closed, so there you go. There are no relative mins here because although this is a low point, it didn't decrease before. There is a relative maximum right here because we did increase, decrease. And then they get to practice their piecewise function writing. Over here is my scratch work where I used point slope form, and I decided to rearrange it into slope intercept. I don't know if that was worth it. As a matter of fact, I just added the 3 over at first and I wrote it like that, and that's perfectly fine. But then I thought a lot of my students were going to maybe rearrange it, so I went ahead and did this. I would take either one of these, and they get to express this. When they are writing these, they need to make sure they don't put an equal on both of them, but they do put an equal on at least one of them. Could be on either one, because when I come to this function and I want to plug in 3, I need it to definitively tell me plug into the first rule or plug into the second rule. As it turns out, it doesn't matter because both places I plug in give me a value of 6, this side or this side, but I need one and only one of those to have an equals. So that's an important piece to go. And so they continue to work on that, and the graphs get slightly more complicated as you go. This one had 1, 2, 3, 4 pieces I needed to write for. This one had only 3 pieces that I had to write for. But it's very nice practice, and they'll fly through these and often have them wrong, so because they're thinking about whys. So please take the time to talk about and check early on before they leave your classroom to make sure that they really know that they should be being careful with the x's and y's. Okay, and that's all there is to that worksheet. I wish you good luck.